Hello everyone, welcome back. Let's say after assigning the loads, everything, modeling, it comes to point for analysis. Now before going to analysis, there's something that you have to keep in mind if you have seismic analysis. Now for the case that we have it here, we defined seismic analysis. So in the load pattern, we have seismic and wind. So for seismic analysis, there is something we call mass for the building. There is something that we have to define. By default, there is a mass source which will take the whole building's weight, will be used for analysis of seismic. Now codes will define different mass. Some code they say that 100% of dead load will be taken, but for live load, you remember we said reduction of live load, the problem with the live load, not everywhere will be full live load. So the code as well for seismic analysis, they said that let's say 20% of the live load, 25% or 50%, or in some cases you have to take full live load according to the building's occupation. So if you don't do this mass source, by default there is one. If you go for show modify mass source, you will see that inside it say element self mass, additional mass. Whatever you have it, it is considered as a mass and will be used for seismic analysis. So that's why sometimes you do it without even knowing it, but Etabs put this one there. Now if you want to follow according to the code, what will you do? You're just going to check those and check them. You specify load pattern. You will add the load pattern that you wanted. So you will take full one of dead load, full dead load, for sure dead load will be taking, but for the live load, I'm gonna take, for example, 25% of the live load. Multiply basically means the percent of the live, or maybe 50% of the live will take it. So now if I keep this way, the mass source will be used for analysis of the seismic will be consider the full dead load, 25% of the live load. The live load will be applied to the building. So this is something you have to know this one. If you keep it the way it is by itself, it will take the whole mass, the live load, whatever you added to the building, will be used for the seismic analysis. If you want to specify it by yourself, we'll uncheck those two, we'll keep this one check, specified load pattern, and it will decide whatever the loads that you have it there. Mainly live and dead, basically. They're not going to add those things there. I mean, the weight of the building, basically, those are the weight of the building. Or maybe you have super dead as well. So if you have super dead load, you add that one as well. Remember, if you have super dead load, superimposed dead load, you will keep it as full as well there. The dead, whatever dead will be considered as fully counted for the seismic. But the live, because we said live not everywhere available, they have some reduction for the live according to the building's occupation. You have to find this one where? Within the code. Within the code you can find these regulations according to building's occupation, multi-story, normal house, whatever it's the case. Maybe school, hospital, you'll find those there. Let's keep it in this way. We'll press OK. It's already there by itself. It will be auto-defined, will be used in the analysis. Now let's say we set everything there. We're going to go for analysis. Now in analysis, before analysis, let me do this one. Now we have, after modeling, let's say we did everything. It's recommended to come to edit and use auto relabel all. Now why do I need to do this one? When we're modeling, we start from somewhere to somewhere, we use different joints. Then the joint names will be different. Now everywhere will be having different names. The beams will not have a sequence. For example, maybe this is B1 here, B4, this will be B14, B13, without any, like, using, let's say, sequencing. I would like to, for example, if this is B1, this is B2, B3, at least to be in a manner that I can focus or find things easier. Not B1 to be here, beam 1 to be here, beam 2 to be here. I don't want this one. In the design and when you do analysis, it's easier for label. Like for example, the label of this one, B19. What is this one? B4. Why B4 is beside B19? From what? This is what? This is B13. Why? I want this labeling to be something nice, at least to be closer to each other regularly to be, if this is joined, for example, joined 1, this is to be joined 2, like this. Or for example, if this is labeled C11, this is C8, why not C8, C9, C10 to go like this? Or maybe in this direction, C8, C9, C10. So this labeling, it's optional, but I recommend you to do it. So I'll go to auto label all, so relabel everything, so the things will be relabeled. Now look at here, if this is beam 11, this basically 16, so where's 12? This is 7, this is 12, so 11, 12, this is 13 will be here, 14 here, this is 15, this is 16, 17, 18. So there will be a sequence between the things that you have it. So the sequence here, if you go to plan, you might see this one also easier. So the name of them, you can see it here. For example, B9, B10. The columns even will be the same manner. So their naming will appear as a sequence. B3, B4. For example, B5 will be given here. This is B. Where's the B? Yeah, B5 here. Then B6. Then goes B7, B8. This is B7, then B9, B10. This manner, it will be easier for analysis design to find things. It does not affect anything. It's only good to find things easier for naming. It will be useful for naming. Let's say we did this one. We will come to analysis. In analysis, what we have to do? First thing first, we'll check the model to see if there is any problem in the model, in the supporting, in the connections. Maybe we have something problem. Well, we'll click on the check. We check everything, select everything here, everything, and we'll just press OK. By default, this will not be selected. If there is any fixing, we'll do that, trim or extend frames and move joints to fix problem. If you don't this one, it will just basically check the things that we have it here. By default, it will trim if there is something extra, maybe you missed it, it will do it for you. You'll press OK. It will go and check the model for you to see if there is any problem there, and it should give you a table or basically a warning if there is any mistake. So the model has been checked, no warning message were generated, so there is no problem with the model. First thing, you'll do this one. If there is any problem, you'll see it from here. I cannot tell you what will be the problems, because depending on the modelings, you may have different warnings. I will give you exact the location of them. Now, if you do this relabeling, so it will tell you exact location, and you can find it according to the, because you know what happened. The relabeling is nice now. You can find the exact location of the warning to go there to see what it will be written for you here. You have to search for it. You cannot find easily, and it's nowhere there to be found. You have to go and search for the error to see what is it. If you cannot find it, and then solve the error, then come back, recheck the model to see everything is okay. Now this is first thing you will do. It's basically check the model. Now the second thing is you do set active degree of freedom. Now what does active degree of freedom means? When you're modeling in Etabs, you may have different cases. Maybe you only have a frame, so you don't want to go for 3D analysis. If you only have a frame, you'll go for XZ or YZ plane, or no Z rotation. Let's say you're not allowing rotation in Z direction. For the case that we have it's building, it's full 3D, it's okay here. By default, it's full 3D. But in case if you want to go for frame analysis, you can select those two as well. You can change it to any of the others. I'll go for full 3D here, which basically it's okay, to make sure it is okay. That's the second thing in analysis. Now set load cases to run. Now the load cases we have it here, those are the one that we want to run. For example, model, dead, live, wind, live. For example, some people they say don't run the model, doesn't matter. You run those that we have it here. Those are the load cases that we want to run analysis. Keep this way. You can just simply, if you don't want to, just click there, don't run or run. Let's say you want to only analyze this building for what? Only want to see the effect of seismic alone. This basically you only do for seismic. You don't want to do analysis for the other one. This is something you can do the analysis whatever you want. What else in the analysis we have to do? Now, meshing. We said that if you have a floor and wall, normally Etabs is meshing them. So there is automatic meshing. Before going for analysis, it's better to check them. So there is an automatic mesh setting for floor. You'll come here, you will just simply say generate mesh. It will do it. You can change the mesh size. Meshing, I'm not going to go into detail of them. It's basically if you have irregular shape, meshing will be important. But in the case of rectangular shapes, meshing, auto meshing, it's totally fine. Now I can reset this one by itself. For example, it can be 1.525 meter. I can change this one. Making it smaller mesh will make the analysis longer because it will be smaller portions, will be more accurate in case of irregular shapes. In the case of rectangular, it's okay by default to be this value, whatever the value is there. So you press OK, it will generate the mesh basically for the analysis. The same thing for the wall. If you have the wall, it's basically automatic meshing will be used there. If not, you can do meshing by yourself. Let's say you don't want this automatic. What can I do? I can select, let's say I'm selecting this slab here. I can go to assign shell and I can find meshing here. See, where's the meshing? It's floor auto mesh option. I can come here, even select different meshing. It's default, or I can select something by myself. Let's say I can mesh it by myself, or no meshing, or basically use different option for the meshing. So something you can do this meshing. I'm not going into detail of them. Leave it as default. If you have irregular shape of slab, this is better to make it smaller in order to make it more accurate. This is by default, they are there. What else we have to do in analysis? Basically here, we're not gonna go for cracking analysis option here. This is, we said that there is two analysis in the you can say analysis and design in Etabs. This is for cracked section analysis and design and ultimate analysis and design. So far I haven't explained these cracking things. I told you there's something we call section modifier. If you don't want crack happen, or if you want to design the building in a case that cracking is very important, that crack is not allowed, especially in the water related something, you can go and specify this cracking option. Some code, they say that for the slab provide this section modifier in order to encounter the cracking criteria. It's basically will not let the, for example, slab or the things to crack, and it will be used for analysis and design. I'll keep this one for you to go and read about it. We call section modifier. You will assign section modifier for the things, then you can check this part here, the cracking analysis. Now we'll keep it as linear. So if you select those things, will be enough. Checking it, setting the degree of freedom, the load case to run, basically the meshing to make sure they're automatically meshing, and then you'll click on the run analysis. Remember, you add every load and you click on the run analysis. It's going to analyze the building for the load cases that we have it. So the analysis done, basically you'll get something. This is the meshing we have it. It's basically, it's meshing, automatic meshing. You have it here. It's automatic meshing here. You mesh the slab according to the way it is. This is done. The analysis is done. So I have all the analysis. You will see a deformed shape. So whatever the active view that you have it. For example, if I add another view, but let's make this one elevations. I'm not sure for the elevation I have things here because the columns are not on the line. So this is the elevation we have it here, and you will see deformation, whether 3D, whether this one, you can see the deformation. So now we've done the analysis here. In the next video, we'll follow some diagrams to see how can we check the diagrams, maximum moments. There are some other things that we'll explain in the next video.